Hey folks, we're starting off our new unit on climate change, and this is part one of several parts to get us started, and it's all under the topic of climate change, the basics. So right now we're going to focus on the greenhouse effect, understanding how that works and its importance, and also looking at how climate change has changed over history. This will relate to some the history that we learned about when we were studying geologic history. Okay, so by now you've probably watched a lot of the videos that I posted on Moodle, and you already have a good idea of how the greenhouse effect works. But essentially, if Earth was without an atmosphere, if it was like one of our planets or a moon that doesn't have an atmosphere, there would be no trapping of the heat that we receive from the sun. Instead, the molecules of the atmosphere, they absorb the heat that it either directly from being irradiated by the sunlight, or the heat that's radiated by the earth after the earth is irradiated by the sunlight. Either way, they absorb the heat and keep the atmosphere within the limits that supports life on the planet. If we didn't have this layer of atmosphere, if we didn't have the greenhouse effect, life on the planet would be extremely cold. And that didn't make sense, of course. What I meant to say is that the Earth would be extremely cold, and it would not be able to sustain life, at least as we know it today. One way you can experience something like the greenhouse effect yourself is that you've probably experienced this before, is that a car that's parked in the sunlight, even on a very cold winter day, if the windows are up and therefore trapping the air inside the car, that air will absorb the heat from the sunlight that comes in through the windows and strikes the dashboard and the seats and everything else in the interior of the car. And when those structures inside the car radiate their heat back out, it's absorbed by the atmosphere inside the car, and it gets nice and toasty warm, even though outside it can be significantly colder. That's like a small scaled down version of the greenhouse effect. Now, we're going to talk a little bit later about different types of greenhouse gases, but I do want to point out here that not all types of gases in the atmosphere absorb heat. The most common type of molecule in our atmosphere is nitrogen, and nitrogen gas does not absorb heat. It's just like completely unaffected by it. Does not. It's like whatever. It doesn't really care that it's getting illuminated by the sun, or that Earth is beaming heat up into the atmosphere. It's unaffected. The other thing that I want to point out here while we're talking about greenhouse effect is that while the greenhouse effect has been in existence for most of the history of the Earth, of course, over different periods of time, the intensification of warming of the planet has varied. And since the Industrial Revolution, which began, depending on which historian you listen to, some say it began in the late 1700s, others point to around the year 1850 or so. Whatever. The point is that when we started using machines to do work instead of using just manual labor or animal labor, draft animal labor, then that led to the use of a lot of fuels to power those machines. At first we burned wood, and later we started burning coal. And the combination of deforestation and also and especially the burning of fossil fuels such as coal and later oil and gas leads to the production of a lot of carbon dioxide and other pollutants that winds up in our atmosphere. Carbon dioxide is what you get when you burn wood or coal or other carbon-based minerals, and you wind up having through the burning you wind up having the liberation of heat, which is why we burn those fuels, and you wind up also having carbon dioxide gas as a byproduct, as really as a pollutant into our atmosphere as a consequence. Okay, with this slide, I just want to remind you of the geologic timeline. And again, this is a single timeline divided into two parts so that it can fit on one page. And you studied this for your exam that you just took for exam 2. And if you will look, I'll point out like the beginning and end points here with the laser pointer. Let me get that set up. Okay, so here I got this is the beginning of the timeline down here in the Hadean, and we go forward through time this way on this bottom graph, and then after we get to this point right here, you circle all the way back to here to the Paleozoic, and then we go forward through time this way across our timeline. And it's right here in the Holocene where we are today. Okay, right about there in the Holocene. In fact, we would be specifically right there on that line where I drew that little dot. Okay, so that's just to remind you of where we are in the timeline. So what we're going to look at now is temperature change over different parts of the geologic timeline. So on this graph, what you see is, and I'll post these PowerPoints for you to be able to study on your own. What you're looking at here is the last 500 million years of Earth's history and the relative change in temperature during that time period. So let me point out a couple things on this graph. First of all, here we are today, okay, and we see where we start on this timeline over here at 500 million years ago. This line, as it wiggles up and down here, is illustrating the relative temperature on the planet. Now, this line right here, indicated where I'm drawing the arrow right now, my really poorly drawn arrow right there, that dotted line represents the boundary where above that line, temperatures are so warm that there are no polar ice caps. The Earth's very warm, no polar ice caps. Below that line, the Earth is cool enough that it's got polar ice caps. Okay? Now, what you see here are, as you look at the line in detail, you see lots of variation up and down and up and down and up and down. And we don't have to worry about like that in too much detail. Some of these events that are marked here correlate with the mass extinction events that we learned about when we're learning about geologic history. But what I want you to notice in particular is that in the latest time periods that we've been in Earth's history, just the last few million years, we've been in a relatively cool phase of the planet. And in fact, until very recently, we have been in a very cold phase known as the Pleistocene, and we'll look at that in just a minute. All right, in this slide, what I want you to notice is that we've got Earth's history over two periods of time, and one of which is much longer than the other. So let's start with this top one. This shows time from about 5.5 million years ago all the way to today, which would be 0 million years ago, right? And on the y-axis here, we've got temperature, okay? And what you see with this, the dark blue squiggles that go up and down, up and down, up and down, are measurements from various geologic data, specifically and especially sedimentary rock and also ice cores that record bits of the atmosphere and the temperatures of the atmosphere from a long time ago. We'll talk more about that later. Basically, what you see here is that for between 5 million years ago and today, in general, the trend has been going down. I didn't nail that exactly with my red line here, but the trend has been going down into a cooling phase. In fact, what you see here in the Pleistocene over the last roughly 2 million years is a time period of what we are known as the ice ages, where things are very cold for a long time and then it warms up and briefly, and then it gets cold for a long time. So the tops of these spikes here and here and here. I'm just drawing little dots on tops of some of these spikes. Those would represent what are called interglacial periods, time periods where it got really warm. Okay, the rest of it, much of the time, was very cold in the Pleistocene. Now, what we're going to do in this bottom graph, it's the graph is set up in the same way. We're looking at time on the x-axis from about 0.8 million years ago to today, which is over here on the right. And the blue line, again, represents average temperatures over that time. And instead of looking at 5.5 million years or whatever it was up the top, maybe 5.25, we're looking at the last 0.8 million years. So that would be 800,000 years of Earth's history. So most of this in this bottom graph, this is taken from ice core data from Antarctica and Greenland. And what again, so we're looking at the Pleistocene only at this point. And what you see is the lines, again, go up and down, up and down, up and down. And again, these where you have these peaks, this would be warm periods. And the rest of the time periods would be relatively cold. So we have like a long period of cold, and then it jumps up to be warm, and then it gets cold again, and then it jumps up to be warm again, and then cold again, and then in this case a little bit warm, and so forth and so on. So the Pleistocene wasn't just solidly cold the whole time. We had these time periods of warming called the interglacials. Now in this slide, what we're looking at is about the last 16 or 17,000 years. So we're zooming in on the very ends of the graph that we saw on the previous slide. So now we're just looking at a tiny little whisker of geologic history. And what you see right here, from here to about here, this would be considered the Pleistocene, all above where I drew that red line. And then right here, where I'm drawing the red line across right now, that represents the boundary between the Pleistocene and the Holocene. The Holocene is the epoch that we've been in for all of human history, or most, sorry, I misspoke there, for most of human history. And let me erase these points for, there we go. What I want you to notice is that in the Holocene, for the last 10,000 years, notice how stable Earth's climate has been. It has been very warm relative to the Pleistocene and very stable. And it's not coincidence that during this time, humanity was able to develop agriculture for the first time and to settle down into city-states and develop complex cultures because we had mastered agriculture. Agriculture was only possible because the climate was stable enough that it was predictable, and we were able to grow crops in a predictable sort of way. Okay, there was still variation over the last 10,000 years. That line still jumbles up and down, as you see, but not as dramatically as we saw in the Pleistocene. So all of that leads up to this slide. This is a graph of estimations and measurements of Earth's temperature since 1850, which is in general considered a time at the roughly marking the beginning of the industrial age, the Industrial Revolution. And the different color lines that you see here are from several different research groups around the world that have been studying the data around this, and they each come up with their own independent assessment of what the Earth's temperatures were like during different times, based on different ways of filtering the data and analyzing the data. And in general, when you map these estimates on top of each other, they all show the same story, which is that even over the last, what are we looking at, 150 plus years, 170 years, we still continue to see variation in Earth's temperature, but we go from a time period where things were relatively stable-ish and cool-ish, and then temperatures start rising. And my red line that I'm drawing here is just kind of averaging out all of that. And what you see here, and especially in this right-hand section of the graph, is the warming that we've seen in the planet this past century and into this century. This is the warming that we're worried about. This is the global warming that's the result of the Industrial Revolution and the burning of fossil fuels and mass deforestation on the planet. So what we've seen here, I've taken you through a walk through history looking at how temperatures have changed from 500 million years ago to just the last 100 from 1850 to the year 2020, looking at how temperatures have changed over those different time scales. What we're going to do next is look at how greenhouse gas concentrations in the atmosphere have also changed over this time and how they're correlated with these temperature changes.